And we're live. So welcome to the first Scaling Now interview. We're talking to Björn and Max from Parity with Arthur here. I will give my introduction really quick. I'm Griff. I am leading the exploration into scaling for Giveth. And Arthur?
I'm Arthur for Quasia, and I work with social coding over Giveth.
And over on your side, guys?
So we had a bit of a lag over here. Yeah. Hey, I'm Björn from Parity, as you were so nice to introduce me, and I'm Max from Parity. I've been coding on the bridge for the last couple of months.
Max is the man for sure. Max is the man of the hour, so pretty excited to have him on this call. So I just want to give a quick understanding of the audience for this call. This is not a general interview for. Oh, and we have RJ. Let me get RJ. Let RJ introduce himself.
Hey guys, sorry I'm a bit late. It's early here.
Yeah, we're crossing pretty much every time zone that exists because Arthur and Quasi and I are in Thailand. RJ is in the West Coast, and then you guys are hanging out in Europe. So it's amazing that we're all here at the same time. Okay, so just to give a scope, you guys are working on Polkadot and probably other long-term scaling solutions. The purpose of this interview is really to take a deep dive just into the bridge, and because we're focusing on dApps that need scaling solutions right now. Also, the audience is a very high-level technical audience. We're talking competent devs that are working in the Ethereum space on a dApp right now. They're considering using a sidechain. They've already been noticing that their scaling issues are real and it's not going to work on the mainnet. And so they're already interested in what you guys are doing, and they're looking to launch in 3 to 6 months, if not sooner. They might not understand all of the infrastructure behind Ethereum development because there's a lot going on, and it's really easy to come in from an outside space and be and kind of be overwhelmed with how deep you have to go to understand what's going on in Ethereum. I don't think anyone honestly understands all the things that are going on. So don't be afraid to give a little bit of background knowledge for defining terms and stuff like that. But for the most part, remember who we're talking to, really high level guys. So yeah, well, I just want to start off by talking about something that threw me for a loop. Bridge chains may not be side chains. Can you guys explain that a little bit?
Well, we can give it a try, right? So I think the concept of sidechains is mostly pretty well known from the Bitcoin space, where we've heard things like merge mining and so forth. So when we talk about bridging or bridging chains, then generally we, at least in Parity, we assume that there are two chains that can live by itself, so that each chain provides their own means to come to consensus and maintains their own integrity. So let's assume one chain is the Ethereum Foundation main network, right? We have proof of work, we all know it, we all love it. And then there's, for example, a POA network, which is a proof of authority network. For example, Coven, right? And in Coven, right, we don't have proof of work, but rather we have a set of validators, we call them authorities, that have their identity at stake, so to say, right? They are well-known startups, dev developers, so forth, and they say, hey, we run a validation process and we provide means to maintain integrity of the network. But like, generally speaking, these two networks can live by its own, on its own, right? And now when we talk about the bridge, we just provide another piece of the puzzle, a software that allows bridging from one chain to the other. Right?
Okay, well, yeah, that leads right into my next question, which is, how does this bridge actually work? My understanding is that you have a smart contract on both sides, and a group of authorities are kind of acting as relays that interact with both contracts on two separate chains. Maybe you can dive into that a little bit deeper.
Yeah, so what the bridge in its current form does is
it implements an ERC20 token on one chain, which is backed by Ether on the other chain. So what you can do with it, you can deposit it, as I said, it's 2 smart contracts, and it's these relay processes. And those relay processes might be the authorities of the POA chain on the one side. They don't have to be. And you could deposit Ether on the home chain, and then the bridge authorities will pick up this deposit and relay it to the other chain, and then make it available there as a token balance, and the other way around. And on the foreign chain, the other chain, you can basically use it as any ERC20 token. So to make that, Griff, can you still hear us?
Yeah, I can hear you.
So to simplify that a bit, right? Like we moved it through, right? We designed the bridge initially based on 2 assumptions, pretty much. Number one is that the home network, so one side, one of these 2 networks that we want to bridge, is a network where the transaction fees are quite high. So, for example, the Ethereum main network, proof of work, and the other network, we have a network where transactions are almost for free or considerably lower, at least, than on the one network. Yeah. So to walk you through, right, how that works is, let's assume I'm the Ethereum main network, and here Max is the Coven network, for example. So on my network, right, on the Ethereum main network, there's a contract, which is looks a bit like a multi-sig, but not like the multi-sigs we have out there. And this contract just accepts Ether, right? Like Ether, the native currency of this chain, right? Now, we have a bridge software. So, and this bridge software is a piece of Rust code. And this piece of Rust code can connect to 2 parity nodes. It does connect to 2 parity nodes. One of these parity nodes run a full node of my chain, so the Ethereum main network. The other parity node runs a full node of this guy's chain, right? Mm-hmm. And the Rust code, so the bridge code, looks into both chains through these parity nodes and watches contracts on each side. Right. And if you look in our documentation, right, the home is always what we call the high transaction fee network. So the Ethereum main network, and the foreign one is the Coven, for example. So now, let's assume, right, somebody sends Ether on the home chain on the Ethereum main network to this contract. Then these people that run the bridge, they see that, acknowledge that through their bridge software, and kind of sign a message saying like, hey, we have seen there's Ether coming in from that address, right? And all the authorities that run the bridge, these bridge software, that can be like however many you want. It could be 1, but it can also be 10. They do the same thing, right? They see it, they say, oh, I've seen it, and actually gone in there. They wait 10 blocks maybe until we assume that finality, has been reached, even though it's probabilistic finality. Mm-hmm. And then the same amount of tokens is minted on his chain, mm-hmm. in his contract. Yeah. So here's an ERC20 contract, ERC20 token, that always with the total sum, right? Mm-hmm. The total supply always represents however many Ether are on my side, on my chain in this contract. Yes. And the main application at the moment that becomes possible through this is that on this POA chain, this foreign chain, my side, I can do transactions essentially for free because I can get Ether from a faucet. So I can use this for scaling, rather than having to do all the transactions on the mainnet where they are fairly expensive. I can just deposit the Ether into the bridge, get the tokens, and then do whatever many transactions, which are also with faster confirmation times, and then I can withdraw it at any point. And the trust slightly changes. I no longer trust the very proven Ethereum proof of work mainnet. I have to now trust a supermajority of the authorities of the bridge or POA network. But then I can have a lot of scalability on this side. So a deposit and a withdrawal costs is about the cost of 4 transactions on mainnet that just move Ether around. And after those 4 transactions, I'm basically breaking even, exactly. So like I'm always a bit careful with calling that a solution, right, for scalability, because is actually scalable enough to allow for all these applications that we're seeing around.
Sorry, I don't know if you're breaking up.
Is it better now?
Still a little frozen. What?
Can you guys hear me?
Okay, you're better now.
It's better now, right? Please tell me. So, like, I'm always a bit careful with calling that a scalability solution, right? Because after all we want is a permissionless public blockchain where this stuff can be run on. But I mean, we have seen fairly lot of projects out there, right, that are have been working so hard on their dApps for a long time, and they are in a state where they could deploy their smart contracts and applications on the main network theoretically, but they couldn't run it because it's just too expensive or the network is clogged. So I think it's really fair to say like that, at least for, it could be a temporary mitigation solution, right? To allow these developers and like all these teams that have been doing this hard work to really test out their applications in the same environment. Because after all, you know, the state machine on Giveth, for example, on the POA network and the Ethereum network is the same thing.
Yeah. So
like you can test the smart contract as you want. And then once we get to a point where the Ethereum mainnet actually scales, right, with Casper sharding mainly, right, they can transition back.
Yeah.
And so there are a few things to consider, right? Like, number one, what is like the trust model behind the whole bridge or this whole concept of running your app?
Sure. Before we go too deep into that, I do want to talk about, Arthur had a couple of questions, more technical questions about the bridge setup.
Yeah. Yep.
So the case that you went over when you were detailing it, that was mainly the deposit process, and it seems like the solution that you've created for the withdraw process is a little bit more interesting. Could you go over that and sort of the gas influences that led to that decision and how you engineered it, I guess?
So the bridge is asymmetrical because we assume that OneNet has much higher transaction costs than the other one, and we want one of the use cases right now for the bridge is specifically to save transaction costs. So the deposit case is really simple. All the authorities make a call into the smart contract on the cheap POA network. Where their gas costs are 0 if they are the POA authorities, or very little if they are a separate set of bridge authorities. And we just collect their calls. And once a supermajority is reached, we give the recipient the tokens. The other way is a little bit more involved because we cannot do the same thing on the mainnet because it would require N, where N is the majority, supermajority transaction on mainnet, which is pretty expensive. So what we do is the bridges call back into the foreign chain into the basically my contract, the POA network, to collect signatures there, and they're kind of getting bundled together. And then once enough signatures have been collected, the last signature providing authority is kind of chosen at the moment to do the relay, and the relay is then one single transaction on the main network, which sends all the signatures as well as all the data required to do the relay and signatures on that data, and is then accepted by hopefully by the home bridge. So it's basically just an optimization thing to save transaction costs on the mainnet, which makes this withdrawal a little bit more involved.
Can you mute?
One thing though.
Can I just check something on that? So it sounds like the signatures are made from a key from keys that are being used on the bridge, and or wait, is it the bridge or the actual foreign net?
So ideally, for this to be really secure, those are the same. So
okay.
But you could have differing there.
Okay. So let's assume they're the same. So basically, you're just aggregating the signatures, and they should be the same in the bridge contract on mainnet, the bridge contract on foreign-net, and the relay. If they're all the same keys and they're being used on all three of those contracts, or I guess the bridge is not a contract, but then you're just aggregating those signatures and putting in one spot, and it's still the same trust model as the deposit coming in.
I don't know if I understand. What do you mean by the deposit?
Sorry, I guess the deposit doesn't have a trust model, but basically there's you could see it as a multi-sig, and you're just aggregating the signatures over here where it's cheaper than aggregating it on the mainnet.
Exactly. And exactly when you talk about the trust model, right? These bridge authorities, how we call it, we can specify if it should be a supermajority, majority, like all of the authorities that have to provide a signature for relay in either direction. So you choose, like we can choose to, we can specify that in the contract before the bridge is deployed or when it's redeployed. Right. You could potentially make that upgradable with like some kind of governance model in the contract where, like, if a majority of the authorities vote for like reducing this threshold, right? But there's one thing I would add to the former was, even though we did this optimization of having only the end authority to relay kind of, the set of all gathered signatures to actually make the withdrawal transaction on the Ethereum main network, it can be anyone to actually submit that. Yeah. So if this authority went rogue, right, and said, like, oh, fuck that, I'm not going to like relay that, I'm not going to submit it, then either the next authority does it, or we even have a way to allow any user. So the user maybe who want to restore to just take it and submit it. And yeah, we try to keep the bridge fairly robust in that sense that nothing, I mean, one of the goals is definitely that nothing can ever get stuck completely, which it
attack vectors.
Yeah, that segues perfectly into the next question, which was in your design, I saw at least a couple places where you were acknowledging and providing solutions to specific attack vectors. Could you go into some of those and the sort of solutions that you are providing?
Yeah, we had an attack vector recently where the authorities on the main, so the addresses on the mainnet for the bridge authorities had to pay for the relay costs. So one could potentially provide them with an initial balance and then let them do the relays, but this opened an attack vector where one could basically deposit a very small amount of VAI into home, have it as token on the other side, and then just make one VAI transfers back, withdrawals back. And every time the authority would try to do the final withdrawal call on the home side, they would spend significantly more VAI or Ether to do the relay than and with a very small amount of depositing a very small amount, I could basically exhaust authorities' funds on mainnet, which is real Ether. So we solved that now by having the recipient pay for the relay gas costs by basically subtracting that from the value that's get paid out on home, and giving it back to the sender, which is the authority or anyone else who does the actual withdrawal call. Was it clear? So it was mainly about like, hey, on the Ethereum mainnet, whatever the authorities, right, the bridge authorities, when they submit a transaction to the contract on the main chain, right, to give out the ether again to the user, they have to pay for gas. So like somebody could exploit that by just withdrawing like 0.001 ETH, and then the authority has to pay for gas every time again, right? Yeah. And then at some point, the bridge authority has no ETH anymore. Yeah. So like that's the point. And how we mitigated that is by subtracting whatever the cost of the relay is from the value that's being relayed. The idea is that authorities don't have to don't up in any way, because they either get paid for the relays, or in the other direction it's even better. We kind of still based on the assumption that the POA authorities are the bridge authorities, and they could do free transactions anyway. And if they weren't, that wouldn't be much of an issue either, because topping up with a faucet on a POA net is much simpler and it doesn't cost anything. The real issue is the part where real ether is involved, and there's really only one transaction in the entire bridge that where real ether is involved as real relay cost, and that was we kind of had to modify that to close this attack vector. Yeah. There was a second. Yeah.
Oh, well, I was just gonna carry on to some more questions. That's okay.
There is another.
Okay, so just
open, but like, yeah. And it's fairly interesting for, I think, smart contract developers. Yeah. But like,
let's hear it.
Yeah, definitely.
So we found another one, which is like, we kind of like the system to not have to rely on any single bridge authority to actually relay the withdrawal, right? And allow any bridge authority to actually submit the final transaction, right, with the gathered signatures. And also allow like people beyond the bridge authorities, like the user maybe who has like the ether deposited, to submit this final transaction. But the point is, the problem was, we said before like that whoever like actually submits the final transaction gets whatever gas cost, right? They pay for it. Now imagine Max was going to do the submit. Max was going to hand in, like, say, I want to withdraw that much. A lot of the authorities provide their signature, and I'm the last authority. And I like sign and hand in this withdrawal transaction, but put a gas price of like 100,000 GWay, right? Then the whole transaction value would be drained. I wouldn't win any money. I wouldn't get any money, but he would have lost all his money. Right? So that is kind of interesting, I think. Yeah, we found that yesterday, and it's a fairly easy fix, which makes, actually, by fixing it, a lot of other things become easier. So this way we're still constantly improving this. And we need users and a lot more people interested in the project to really polish it and find all those remaining issues.
Okay, well that's pretty cool. Just a couple questions from the crowd while we're on this topic. Just a quick obvious thing: anyone depositing ether into the bridge is trusting the authorities. This is from D-Tense, by the way. He says authorities of the bridge chain can theoretically steal the ETH, right?
So no. Now we got to be really precise, right? And that's why it's a bit difficult, this whole conversation, is because on one side you have the POA authorities, right? The authorities that maintain integrity of the bridge chain. And you have the bridge authorities. They can be the same, they don't have to be the same. So you really only trust your ether. So the ether on the mainnet, because it stays on the mainnet after all, right, in this contract. You only trust the bridge authorities with that ether. Not the POA authorities, because let's assume we have the system running and running and running, right? And on the POA network, the tokens go wherever, right? Distribution. But on the main network, they stay in this contract. And the ones that can unlock it and like send it off are only the bridge authorities together. So like even if the POA authorities were completely compromised or the chain was shut down, the Ether wouldn't be lost. They could still be sent off. So in some, and that's now the question of the trust model, right? But if you would say, for example, it's like you guys, Giveth, right, that need to use that, and it's Status or like Aragon, and you kind of want to connect your dApps, right? You want to live on the same chain. So now you can have two things. For example, you could use Coven as it is, with our authorities as they are. No, you are not part of it yet, but like, but you could, for example, deploy the bridge. Like we could have a testing deployment together with these teams, for example, or just two of them. So you wouldn't have to trust any of the POA authorities by managing the bridge. But anyone who uses the bridge has to trust the bridge authorities. So in most cases, it probably makes sense to have them be the same set and have the bridge track the validator set of the POA network, but it doesn't have to be like that.
I mean, it could be that there's this one sub-network like Kovan, for instance, and then maybe Argon, Status, and Giveth want to do a bridge, but maybe Melonport and Digix and some other Kovan guys want to do a separate bridge. Right. So there'll be multiple. There could be multiple bridges between the.
The thing is that a majority of whatever chosen majority of the bridge authorities can always withdraw all the ether deposited on the house side. This is, I think the security model overall is much more sound if the bridge authorities are the POA authorities, but you can do, this is a really interesting use case that Björn just described.
Or as many as possible, right? So like, right, if it's just you guys, for example, then everyone has to trust you that you never run off with the ETH, right? Even though the users kind of control it on the POA network. But if you guys if we have like 10 teams be the bridge authority, right? It's better for each team, kind of. Yeah.
Okay. So another question from the crowd. Actually, Peter asks, can you explain what each of the 4 mainnet transactions do? I think there's only 2, but I'll continue the question. Why can't there just be 2 transactions, one for locking the ETH and the other for withdrawal? I'm pretty sure that you said that it costs the amount of gas of 4 transactions, right? And that it's actually just 2 mainnet transactions?
The withdrawal costs about 3 times as much as the deposit.
Okay.
That's it.
And the deposit is like almost a regular transaction on the main network. So what he kind of meant is like when you have any kind of dApp with the user for each like input of ETH does 4 transactions or more, it's already better than on the main network, right? And if you deploy contract as a team, then that's not even a question, right?
Oh yeah, absolutely. So basically, there's one deposit transaction that maybe shoots off an event, and that's the extra cost, I assume. And then magic happens in the not side chain, the bridge chain, and then the withdraw transaction has a lot of extra data, and it costs about 3 times of a transaction, and that's it. That's all the gas you'd have to pay on the mainnet.
Yes.
Okay, that's pretty magical. Well, let's change.
I got one quick question.
Okay.
One last one. What type of batching of withdrawal transactions?
We could look into that if that becomes an issue. We could definitely do something there. We haven't looked into that yet.
I mean, you guys, right? Giveth just created this contract, right? I think.
Yeah.
Arthur.
Right.
Exactly. So obviously you could use that for it, right? And the authority doesn't send for each individual one, but batches it, gathers it.
Right.
Sounds like a sensible idea if it's secure, right? Why not?
Yeah. Let me just give props where credit is due. Alexei from Kiev, Arthur, and Alon, they're all contributors to Giveth to an extent. And Alexei's a white hat, a famous white hat, at least in my mind. And they created this great multi-send transaction that we did a trustless deploy where it goes on, where it's the same address on Ropsten and on mainnet, so you can actually test it on Ropsten and make sure it works and use the exact same raw transaction on mainnet. So it's pretty. And it's also it's trustless and it's open. It's not a private contract. So you guys could actually just make that send without doing anything. You could just use that contract. It's still being tested though.
Yeah.
Okay, so let's go to talking about that chain that's being bridged to. Quickly though, POA versus POS. Do you have ideas that people could use a POS chain instead of a POA chain, or what are the requirements there?
So currently, those that are familiar with how the Parity client is built. We have something we call almost pluggable consensus, where you can switch the consensus engine. And that's why you can use a Parity client for like the Ethereum main network, but also for Coven or like your private POA network. The nice thing about ours and like how we implement it is that you can have the validator set. So like kind of this piece of information that says who are the validators that maintain integrity of the system is contract based. And you can have arbitrary rules implemented in a contract that say like how this validator set should be updated from block to block, epoch to epoch. That means currently we have only POA, right? You can have the like a governance rule majority vote. If like the current Coven authorities vote and say like, hey, this guy should be onboarded, he can be onboarded. But that also means you can implement POS in there, because you could have like whoever holds that much ETH there is an authority in the next round. So, and fundamentally, the bridge doesn't care about that, right? And this is like kind of the next step from where we are right now with the bridge. Right now, the bridge, when you deploy it, which means when you deploy the contract on the main network and the POA network, you specify which address is an authority for the bridge. But we want to change it to probably 2 phases. Number 1, we want to add some kind of maybe majority vote so that these set of authorities can like add an authority or remove. And the next one is that it just relies on this contract of the consensus engine. So like whatever the POA validators are, the authorities, the bridge authorities are the same. So it's kind of plugged in, which would make it a lot easier later. If you say like, hey, you guys have your own POA chain or for Coven and stuff like that, right? If a new authority is onboarded for the POA chain, he's automatically also an authority for the bridge.
Oh, that's pretty cool. That's actually really cool.
We're actually looking into implementing a POS based on that. So just as an outlook.
There's a question from D-Tense that's along these lines. Will Parity support dual chain mode plus bridge, running one process instead of 3?
Probably not, I would guess.
Can you ask him why he wants that?
Why do you want that, D-Tense? It might take a while to get a response. But.
Yeah, it's like Parity is a specific thing and the bridge is a specific other things, and bundling them together probably doesn't make sense in my head.
It's a question, what are the other benefits, right? Like I had David, our DevOps guy, was so nice to look into how much that would actually cost in terms of infrastructure to be an authority. And it might be something between $10 and $50 a month, or let's say $10 or $100. So it's not even much. You can run on one VM these 2 Parity nodes plus the bridge.
So the bridge is just a process. Like you're just running this process, and you're running 2 nodes, and that's what it takes, all in the same VM. That's what it takes to do this. That's it.
Make one bridge authority. Yeah. And each authority.
Okay. So.
Yeah.
Okay. Well, that's not too shabby. Okay. So now the question is, if I'm a DApp dev, what do I need to consider if this approach is right for me? Like what if, let's say that we're Giveth, might as well use us. What do we need to be considering? Obviously, gas prices. Go ahead.
I think I know where you go. Maybe I would even split that conversation into multiple parts to make it a bit easier and clearer. One interesting discussion is like, hey, where's the bridge and its contracts right now as it stands? Where can it go? And what does it mean in terms of extensibility and so forth? Right. And then also, like, you guys, in the sense of, hey, where are we testing production, right? Is it secure, safe, what has to be done? And then very specifically for Giveth, right? And like Max and I, we had a look at your document. Like we briefly skimmed the, what was it called? The scalability one from Giveth.
Yeah, tackling scalability, exactly. Our little Medium post.
Exactly. And
I think for you, it could be really useful to remove this element of centralization from this entire approach, where people no longer, where you have a bridging of value, and then on the side, on the POA chain, you can do a lot of transactions and you're saving a lot of gas, but you still have it backed by the Ether and the main chain through a mechanism that where people don't need to trust you exclusively, but they can trust, for example, the Coven authorities or another bridge authority set. So it's more of a trustless bridging, or a trustless,
so
by Ether.
If a DApp team is thinking, hey, I think we have a DApp that's ready to go, and we really want to start testing it, why should they choose the bridge over doing a centralized thing? You'd say, well, because it's a little less centralized. And then what other considerations do they have to have? Like, is there something that they might have to do to their DApp to make it work for the POA network? Or okay, are there any? Can you think of any generalized DApp questions that devs should have in their mind?
Yeah, let's look at it this way. From your perspective, Giveth, right? You had these three phases, right? Number one was like, hey, please tell me if I'm wrong there, right? But as far as I understood, phase one was just like, hey, we have a multi-sig on Ethereum. People can send their ETH in there. Fine. We will look at that. We will mirror kind of the thing somehow manually on the Ringby network, and then do all the processes there. But it's kind of like an accounting system. Everybody can see what happens, but like there's no user interaction on the Ringby network, right? Like you don't
So this is I was asking a misleading question. So one of the things that DApp developer obviously needs to do is they need to make sure that if their DApp was made to work with Ether, now it needs to work with an ERC20 token. Correct?
Yeah,
like,
work with the token.
And are there any other changes that are similar to that may need to be implemented before we go into Giveth? Because don't worry, I'm going to take this opportunity to get you to walk me step by step how I'm going to do this with Giveth, right?
I mean, and that's a point where it's like where it is right now and where we want to take it. So right now we have on the phone one the ERC20 token, right? And right now the bridge as it stands, let's say we deploy it next week as a testing between Ethereum Coven. Then when I'm a user on the Ethereum network, then I would, I'm a user on the Ethereum main network. I send a transaction into the bridge. Then the key I use to send this transaction is the same key that owns the ERC20 tokens on the POA network, right? So that means if a DApp wants to use that, then you require the user who sends the ETH to be also active on the test network afterwards, because he owns the same tokens, right? So as it currently is. Currently, the bridge could be deployed per DApp. Like a DApp developer could say, like, I'm the only bridge authority. I only deploy that for my DApp, right? So whatever tokens, whatever users I have, I just say, like, the foreign side is only supposed to be tokens for my DApp, right? And they could probably modify it to be kind of their contract already. So yeah.
What we're aiming for is, so right now we really only map Ether to one ERC20 token. What we are aiming for is a much more generalized solution, which will probably be based on an ERC 777 token and this iToken receiver, ERC 820 registry, where people can deposit Ether on the main network, and then it will be deposited in the foreign bridge, but the foreign bridge would then deposit it automatically in a user-defined token. That is just an iToken receiver. So, and those users could deploy their own token with their own business logic and on foreign, and this would enable a lot more use cases and reuse of the bridge without having to modify the bridge itself. So this is something we're aiming for, to build kind of a more like infrastructure that people can just deploy and then hook into their own things. And with this ERC 777 solution, you could have multiple data without having to set up multiple bridges, for example.
I mean, you can already use the same bridge, but the fundamental difference is that, for example, the dApp on the main network, right, when it tells the user, hey, send Ether to this contract, could already tell that this transaction contains some data, as is possible in ERC 777, right?
Yeah.
And in this data piece, it could, in this message, it could say, you know, actually, I don't want to just, the user doesn't only want to own or hold these tokens on the POA network, it should be sent straight away further to the Giveth application, right? So like you could insert already other actions in this message passing, and that is why it would become way more general. But I mean, even in the current state with the ERC 20 solution on the foreign, on the bridge chain side, every dApp can use it.
Right.
Yeah,
it's like,
the dApp would just need to make sure that their UI is kind of playing this game where, I mean, at least what we do, for instance, for this solution is we actually just use the donate through My Ether wallet. It's not necessarily a dApp button. It's not a Web3 button. It's just data injected so that if someone can click donate and then they can donate Ether. They get sent to My Ether wallet with all the information for the send preloaded, and then they load their key with MetaMask or their ledger or whatever they want to use. And then when they go to the dApp, they're still on the test net or whatever network we use, and all the other buttons are doing the normal thing. So they could probably do a solution like that too. With the current setup right now, that they could deploy it right now and it would work. Right?
Yeah, sure. Yeah.
Okay, so then let's walk through what it'd be like for Giveth to do this. So we have our dApp. Right now, we're already rewriting it so that we're passing tokens around instead of Ether, which is step one. We're already working on the user experience part, like you said, where when people actually donate in our dApp and send Ether, already they don't have to, if they send Ether in, I believe the token, maybe RJ could correct me on this one, when they send Ether in, then the token is actually already sent to the delegate or to the campaign, and the user wouldn't have to do anything with it after that because it's already in some other authority's hands. But in this bridge, if this bridge only puts it in as a token form, how would that work? Do you understand what I mean?
The Ether you just described was on the mainnet, and all the contracts were on the mainnet, right?
No, so on the testnet, we have, so when someone clicks donate, well, maybe RJ, could you explain it? I think you understand what I mean, right?
Yeah, what you're talking about, well, donating on mainnet and having it go to the endpoint on the testnet, is not really possible right now unless we were a centralized relayer and we had like, well, yeah, we just sent custom data in our mainnet contract or something, or we use this 777 solution that they were just talking about.
So right now, we would still need the user to actually do something on our dApp with the like donate a second time, basically. Is that true, RJ?
Yes, or like one intermediary solution we were talking about was having where we were running a relayer, and then we would have separate contracts, or our relayer would be reading additional data and send it to the right place. So the user didn't have to touch it twice, essentially.
I guess with the bridge, what you could do is have a user donate on home and then have it automatically get relayed, or have it trigger one of your contracts, which then does something on the bridge contract. So have this donation automatically reach some token contract on the foreign chain.
So we could actually modify. We could actually modify the smart contract on the bridged chain, the foreign chain, so that it plops instead of making it so that ERC20 token is given to the user, we could just add a couple functions in there.
Look, the fundamental question is, right, do you want to have any user interaction on the bridge chain at all in the long run or not? That's question number one. You want. So if you say that, then I don't see any problem with like using the bridge as is at all. Because right now, right, you can have the user click a button, the ether is being deposited kind of on the other chain. It has the ERC20 token, and then you have the user be on the testnet and click another button, say like, now you actually donate to Giveth. And then it can interact with you. So
for our use case, it's nice to give them the option. So like what happens is someone donates, let's say, to a charity that's a generalized charity for animals. And so when they donate, they get assigned a delegate, and that delegate has authority over their funds. So like when they're donating, they're going to be donating to something. They're going to donate. They're not just going to be like, I want to use Giveth DApp. They're going to be like, I'm going to donate to animals. I'm going to donate to kangaroos. I'm going to donate to this specific kangaroo charity. Or I'm going to donate to this specific kangaroo's charity's milestone, right? And they could pick any of these, and then depending on that, they would get different delegates, different people who have authority over their funds. But and then what we do is we send an email out when, let's say, the general animal charity guy sends it to this kangaroo charity, and that kangaroo charity has a project that's going to lock up those funds. That's going to the original giver will then they'll end up losing authority over their funds after that. So we send them an email and say, hey, in 3 days, if you don't click a button, then this charity is going to get your donation. And in that circumstance, we want them to interact, but we want it to be easy. If I'm a CTO of some blockchain entity and I don't have time to sleep, but I want to help kangaroos, I just want to click a button and be done. And
well, right now there are two options, right? Either you modify the contract on the front side to be very specific for your Giveth, right? So that instead of the user receiving it on the other side, it goes straight to you, right? But then actually you just take the bridge as it is, you deploy it, you're the only authority, it's all yours on the other side, right? And you don't really need any user interaction. Or number two, for example, we work together to extend the contract on the front side for ERC 777 and thereby solve the problems for everyone that could potentially out there and make it ultra general. And in my opinion, that's a way better approach in the long run, because there's so much great you could do on this kind of testnet. You could use the scalability, like the better scalability of let's say 1,000 transactions per second. You could have this interaction with all these different apps, right? And they would all need the bridge. So you could share the responsibility of bringing bridge authorities and use the same thing, right? I like this approach more, but obviously you could also, if you just want to go ahead right now, change the front side only, make it very specific to your application, and just run the bridge by your own. You don't need to change any line of Rust code. Yeah.
I think 777 is definitely the better way to go, for sure.
We like that. We like
777, baby. It's a beautiful contract. Well, what else would we need to consider to implement this? RJ, do you have any questions for him?
No, I think they've done a pretty good job explaining how the interactions work and everything.
Yeah, so you think you could take their code and run with it?
Well, maybe we could work together and do 777.
Yeah.
I know Arthur would be into it.
There's
Yeah,
one
I've
thing.
already started it. Well, for another purpose, I have most of the like an ERC 777 ETH wrapper done. So from there, it should be pretty trivial.
Nice.
Griff, because you asked what else we need to consider, or what else dApp developers or teams need to consider right now. So there are a few things, right? We've been developing the bridge for quite a while. The first release was in October. We actually only did like testing deployments internally, but never deployed it, for example, between two running networks like Giveth. But here goes credit and kudos to POA network. You will talk to tomorrow, like Igor, great guys. They build a shit ton of really cool stuff. And they've been texting it, I think, for like some kind of demo for a crowd sale. And are currently extending it for their scenario where you have a lot of which one to the other, right? This is slightly a different use case. They use the same Rust code and stuff. They modified the bridge code, the smart contract code, to be suitable to their use case, because obviously in the long run, they don't have the situation where you have like one high value, high transaction fee network and the other one is low. It's slightly different. But like Igor can tell you more about this tomorrow, probably, for sure. But one thing to consider is obviously, like, we would like to deploy it as a test first, right? We are fairly confident it works and so forth, but it should be tested well first and audited. The bridge code, so the Rust code, as well as the contract. Right. So like, it would be awesome if we could make that some kind of community effort. Whoever is like interested in using it, maybe we could work together to get it like tested and audited fairly well. And so we are thinking of doing some kind of testing deployment maybe next week. Just probably Giveth just because it's there, but it could be any proof of authority network, but it's there, why not? With the Ethereum mainnet. And in order to make sure that it doesn't become a huge fuck up, if there's a vulnerability, we are thinking about introducing some kind of limitations. For example, the user can't deposit more than 5 ETH, right? And the bridge in sum can't hold more than like 50 ETH, right, in the beginning. So just to make sure, you know, we don't have a major fuck up. But in general, I personally would find it awesome if like we could get a few teams together that actually want to use the bridge. We deploy it together, right, and just test it. That's something.
Is the POA network the only people that you know that are really pushing this and using it today?
I know that Melonport is really keen. I'm not sure if they have deployed it yet, but they're fairly keen. I've talked to one other guy actually that had deployed it, but I don't know about any like project that has been using it in production actually, right?
Besides POA network.
Well, I'm not sure they are actually using the bridge in production at all, because I think they just use Parity POA in production. So like a POA network in production. The bridge, I'm not sure. You should ask Igor. He knows better, obviously.
Okay.
Yeah.
And then one of the big issues with using a POA network as opposed to Giveth is that there is no block explorer, right? For the POA network that shows internal transactions. Mm-hmm. Do you know of any groups that are working on that, or do you have any like ideas on how to mitigate? Is there an open source one or a option to see ERC20 token transfers? I think there is, but I'm not sure.
So I haven't come across any open source explorer that comes nearly close to the functionality that Etherscan offers. Unfortunately, we are all aware of that problem, and we've been working internally also on like some kind of dApp, right? You can use, but like I wouldn't even propose that, because honestly, we need a really good solution for that. I know Igor has been proposing to work on that, and we've been talking to him also. Like, we were interested in collaborating to some extent. I mean, it would be great to have an open source software, but for Coven at least, right, it works because Etherscan put us to Max, to Matt. He's like providing this service for everyone. Yeah.
Yeah, Matt is a hero for sure.
Yeah, I don't know any team who actually offers a very good open source block explorer currently.
Yeah. Okay, cool. And then, yeah, I guess it's time. Do Quasia or Parasology, do you guys have any questions? Otherwise, I'm going to go to the list I have over here. Okay.
Even though, one last thing regarding block explorer, we have to make a quick shout out. I think the Ether Chain Light Explorer, right, from Peter Pratchett, I think. It has really helped me in quite a lot of projects, so I'm really thankful for that. But like, it lacks functionality, obviously.
Yeah, I wonder. Another one is Ethplorer. In fact, I'm in Thailand, and so are the Everix guys. I think that make Ethplorer, and at least that works for ERC20 tokens. I wonder if they'd be interested in deploying that. Because you just need the token explorer, right? That's what you really need. Although for dApps that use like our dApp that uses a lot of complicated function calls and like donate or withdraw or moving pledges around, it would be really difficult to do that without a beautiful Etherscan. So, okay, RJ, I saw you on mute. Do you have a question for him?
I was just gonna say no.
Oh, okay, perfect. Okay, so I got a list of questions over here that Lindsay is putting out from YouTube. So we have, this guy promises he's not trolling. Why not use ETC as a sidechain?
Because it also has high transaction fees and it doesn't scale.
Yeah.
I mean, it's not as scalable as like a POA chain where we can achieve way higher transaction throughput, right?
Yeah, and it also doesn't have a block explorer worth its salt, so it's not going to work. And then we have, authorities should have unexhaustible balance so they don't even need to top up, meaning they always get back what they spent in gas. Is this true?
Right. So assuming that the POA authorities are the bridge authorities, this is currently completely working like that. We will have to do slight adjustments if the bridge is deployed in other setups. But it will all be along the lines of what we already did, where basically the recipient will probably pay for gas, or we'll find mechanisms.
Actually, it's almost trivial at this point, because what Max just said is like, if I'm a POA authority and I mine blocks, and I'm a bridge authority, I just put the transaction for free.
Yeah.
And now, if the bridge authorities are not the POA authorities, we have in the Parity client, we have this option that authorities look into a contract where you list other addresses that don't have to pay for transactions. Yeah. So you could just say like, hey guys, for example, in Coven, everyone would just say, yeah, sure, bridge is awesome. You get transaction for free. We just add you to that list.
Mm-hmm.
Or we give you a huge amount of Coven ETH or whatever network you use.
Yeah, that makes a lot of sense. So what about bridge authorities should need to update their commitment regularly, so if they die, eventually people would be able to withdraw their valuables?
That's with the fixed authority set that we have at the moment, that's kind of a problem, because if there's no longer a majority, then the funds are basically frozen. So until then, we should have some kind of escape hedge mechanism for such cases. But eventually, we'll have kind of dynamic validator set. And so the ideal setup in my mind is to have the bridge authorities be the POA authorities and have dynamic validator sets on the POA, which will get rolled out on Coven in a couple of months, and then have the bridge automatically track that, which will solve all those problems.
I mean, it's the same with any multi-sig wallet, right? You need to make sure that these fuckers keep their keys safe.
Yeah.
because otherwise we have a major problem. But like, I think the mitigation for this kind of situation is like have many authorities in the bridge and like have a reasonable threshold. Let's say 60%, 70%, something where you're pretty sure, you know, like if we have 20 teams, we're pretty sure not 10 of them collude to say like, hey, we're gonna fuck everyone over and steal the ether, right?
Exactly.
Yeah.
I actually don't think that's a issue if you look in like proof of work networks, like you have like 5 big miners, right? We can achieve that in the bridge, have 20 teams that everyone know they have a reputation at risk, right? We have our friends. Like I would come over and beat you up if I knew you were going to run away, right? So
Yeah.
it's a different setting, and I think not too hard to find a solution for that.
No, and I definitely like the escape hatch idea. I think an escape hatch should be in every contract ever. So
we are testing. We will be testing for quite a while. We need an audit. We need way more tests. And until then, we need escape hatches. And it's kind of
Yeah, no, I mean, that's the magic of an escape hatch. You put it in at the start, and then you can, once you trust everything, you zero it out, and the escape hatch can be pulled.
This. Once it's finished and stable, we can take it out.
Yeah, trust me, I want escape hatches. Anyway, let's see. We have authorities deposit. Let's see. I believe it is possible to remove the possibility of bridge authorities to steal ether. Authorities deposit ether, and that defines the limit of how much bridge ETH they can issue. When user deposits ether on mainnet, the contract assigns the generation number, ever incrementing, to the deposit, and the bridge ETH issued carries the same generation. Then transfer of bridge ETH updates the generation number of the receiver. What do you think of this idea? This is detents again.
I'm not sure if I completely follow. If you don't have time today for this, I would say file an issue. This sounds really interesting. Just file an issue on the repository. Otherwise,
oh yeah, here, I have the link.
Like, please give a shout out. Like there are two places, right? Our GitHub repository, which is GitHub Parity Tag and then Parity -Bridge, and we have the same in GitHub, so room, and like. We would invite everyone, please come in if you're interested, like talk, let's all talk together, figure out what would be the best approach to that and how we can, provide for everyone. Right.
I just sent those links to Lindsay, and I think she'll put them in the chat for us. So hopefully at least everyone who's participating will get it. Otherwise, it's pretty easy. The GitHub is under Parity Tech /Parity-Bridge, and the Gitter is gitter.im/Parity Tech /Parity-Bridge again. Oh man, well done, well done. Okay, so yeah, I guess I think that's pretty much it. Well, let's talk timeline. So this has been out since October. Is that true?
Development kind of started.
Well, the Rust code was all done in summer. I think by October. I'm not sure with the contracts how much was done. I know, like, there was an initial version at that point. There was a release for sure. I know that the Ego and the POA guys, like around that time or a bit earlier, took it, like, customized it to their use case and used it. We have just, like, when Max joined, we've recently picked it up again, like, a while ago. Like, put a test everywhere, like
fixed bugs, tested, improved documentation,
everything
to make it really stable. Because it's kind of theoretically it's working. We just need to make it more stable and finally test it now.
Yeah,
that's the
so I think the contracts have 100. It's fully ready.
The contracts have 100% test coverage in branch coverage. We are using Solium linting. We have one integration test. We need many more integration tests, and we need an audit, and we definitely need a lot of, we need some kind of fuzzing of the entire system, which we are also working on. There's a Parity Solaris project, which is fairly early, but coming along, which will help us with that. We can do a lot, just exercise the smart contracts in the entire system from Rust and do a lot of, try a lot of random combinations and failures to make it really secure. This is definitely on the
you can write contract tests in Rust with Solaris, and then finally access the native EVM, the Parity EVM, which makes it super fast. That's kind of, but this is supposed to be a community project, so whoever's interested, please join us.
Well, in March, on March 6th, we're still working on the details, actually with Ashley, who's part of the Web3 team. We're still working on the details, but we'd love to do a Scaling Now gathering, kind of an invite only for devs that are working on scaling and developers like yourselves who have scaling solutions, so that we can try to build these coalitions. So hopefully you guys can come to that. It might be 5th and 6th, or it might just be 6th. We're still working on the details.
In terms of timeline, right? Well, it kind of depends what the needs of projects are, right? We kind of just want to get it deployed somewhere to start testing, right? In a live network. That would be nice. But we can either do that, for example, next week by our own. We could say like, hey, you know, it's very clear you guys need this or that or others, and then we go back and like modify the contract a bit further. For example, ERC 777. Or we and when we do that, we say, hey, let's deploy together, right? Like a bridge with a diverse set of authorities. That would be a case. And then later on, when it's tested well, everyone's happy. For example, with Coven, the idea would be, hey, you have the Coven authorities be the same as the bridge authorities, and like have projects like you or like Aragon or people who actually want to use that become Coven authorities. And then being bridge authorities, and in the same way, you just use the network. And timeline-wise, I mean, testing could we start now? We could start now. I think the whole, like having upgradable Coven authorities, dynamic co-validator set on Coven, and this all be like the same as the bridge one. I think like couple of months, yeah.
Okay.
Until that's done. Yeah.
That's perfect. Well, cool. I guess there's one last question from the crowd, actually for Quasia. Is that 777 wrapper public? Is that open source?
No, but as soon as it works, it will be.
Oh, open source it. Come on.
Yeah. No, I mean it's for Aragon, because they need that. So it's going to be in the repository, and then if possible, I'll pull it out and then make it into its own thing. But yeah, all their code's public. So.
Okay, perfect. Yeah, and that would be really interesting because on March 6th, when we do the Scaling Now gathering, the next at midnight, we're going to do kind of because it'll be March 7th, at least 3/7, so 777 launch party. So maybe that would be a pretty cool project to have the Scaling Now transition into Parity Bridge tech, integrating 777 and launching it at midnight.
Right. That would be cool.
Yeah, that would be very cool. We'll talk to Jordy. We'll see if we can make that magic happen. Well, thanks a lot, guys. This was a lot of fun. Any closing thoughts from anybody?
Thanks for the initiative. Yeah, awesome. We just want to see it being used, like stuff.
Yeah. Absolutely. Well, thank you, guys. And the next Scaling Now is actually it's at 9 p.m. Pacific Coast time, which I believe is noon Thai time, and maybe 6 a.m. if you're in Europe. So it's going to be a tough one to view in Europe, but it's going to be with Igor and Roman from POA Network. They have actually implemented the Rust code for the bridge, and they customized a lot of the rest of it. So it'll be really interesting to start with you guys and then transition in the next talk to people who are actually using it. So thanks a lot for all your time, and thanks for listening, guys. See you guys.
Thanks for that. All right.